Okay, I ran out of time when I was talking about this crazy little thing between valence and valence number. So valence is the number of electrons in the outer shell. You can look and see what group an element is in, and you'll see the group number is the same as that number. Valence number means the number of electrons it needs to be full to make that octet, which on everything except the first shell is 8. So here's another example. This has 11 protons, so you can look at your chart and see it's sodium, Na, number 11. And let's double check. It looks like it should have, it's right here, it has 1, 2, 3 shells of electrons, 1, 2, 3, and it has 1 in its last shell. Boom, there it is, 1 in its last shell. The first one's full, the second one's full with 8, and then this one guy right here. So the valence is 1, that's how many it needs, and the valence number, if it's going to react with anything but itself, is going to be 7, which is kind of cut off there, sorry. Going to react with itself, it's going to be full with 2. That's hydrogen gas. All right, let's look at how these things hook together then. So here we have chlorine, and if you look at your chart, it's number 17. So it's going to have 17 negative charges around here, and that adds up to 2 in the first shell, 8 in the next one, and if you look, it's in group 7, so it's got 1, 2, 3, 4, 5, 6, 7 electrons in that last shell. That's that stuff that's going to be so reactive, and it's going to actually steal the electron from this one, this hydrogen, who's only got 1. That's going to make an ionic bond. That's otherwise known as hydrochloric acid, very strong. It's a stomach acid that breaks your food down. And here it is again. I put it with the thing. So you see chlorine, 7 is last shell, hydrogen, 1. Boom. Chlorine gets 8. They're happy. Here's methane gas, as a matter of fact. And so carbon has 4 in its last shell. There's carbons. Oh, here's its first shell. It's got 1 shell and 2 shells. So the first one's full, and the second shell is 1, 2, 3, 4. And it wants to have 8, that octet rule. And if we only have hydrogen available that has 1, then we need 4 hydrogens. So they'll fill it in like this. And that's CH4. And you can see that now carbon has 1, 2, 3, 4, 5, 6, 7, 8 in its last shell. That's what it's shooting for. Then there's this thing called CHNOPS that helps you know which elements make up the most of living matter. The first 4 make up 96%. Carbon, hydrogen, nitrogen, oxygen, and then comes phosphorus and sulfur. CHNOPS, a good thing to remember, that life is made up of these 4 elements. Why? And here's some more information about them, how much of human body mass and all that business. Oh, I didn't have a picture in there, but why is because they are very reactive. They have room to add more electrons, and so they react. All right. Let's go through trace elements a little bit. We also need iron. Oh, here's CHNOPS again. And you'll see that we need 4 here, we need 3 here, we need 2 here, and 1 more there. So that makes them really react often and well. So when they react, they make a molecule, and chemical bonds involve the giving, taking, or sharing of electrons. So they're going to give it away, take it from somebody else, or share it. Covalent bond is the sharing of pairs of electrons. Sharing of electrons, yes it does, but it actually shares pairs of electrons. And so we have oxygen. They both have 6 in their last shell. If you look at they're number 8, and so you'll see that they have 6 electrons in their last shell. Well, turns out they can share 2 pairs and make a double bond. So covalent bonds are the strongest bonds. They're the hardest to break. There can be ones that are shared equally. That means they have the same kind of charge going on each side. So oxygen gas is going to share equally and be nonpolar. But our ever most wonderful water, they're necessary for life, H2O, is covalent. It shares pairs of electrons, but it shares them unequally. So it's shared not equally, unequally. So it attracts the electrons more to one than the other. And we'll do a whole thing on water in just a little bit.